A codebase with 64,000 commits, and Git Bisect finds the exact one that broke production in only 16 steps. Here's the real question. How does one command turn weeks of debugging into 6 simple steps you can run today? Most developers hunt bugs by scrolling commit history, guessing and hoping. That's slow, painful, and completely unnecessary. Git Bisect uses binary search. Instead of checking every commit, it eliminates half the possibilities each time. Start by telling Git the current commit is broken and naming an older commit you know worked fine. Step 1. Run Git Bisect start. This tells Git you're beginning the hunt for the guilty commit. Step 2. Mark the current commit as bad using Git Bisect bad right where the problem shows up. Step 3. Mark an older working commit as good using Git Bisect good and its commit hash. Now Git does something clever. It checks out the exact commit sitting halfway between good and bad. Step 4. Test that middle commit. Run your app, run your suite, see if the bug appears. Step 5. Tell Git the result. Good if it works, bad if the problem's still there. Git immediately narrows the range and checks out a new middle commit, cutting the search space in half again. Step 6. Repeat until Git says this is the first bad commit. That's your answer, found and named. Here's the math. 64,000 commits take log base 2 of 64,000, roughly 16 checks total. 1,000,000 commits would only need 20 steps. Binary search scales that well, every single time. This isn't theoretical. Linus Torvalds built Git Bisect because kernel bugs were getting lost in thousands of patches. The Linux kernel has over 1,000,000 commits. Bisect turns an impossible search into 20 minutes of testing. Manually testing is fine for a handful of commits, but typing good or bad 16 times gets tedious. Automate it. Write a script that returns success or failure, then run Git Bisect run with that script. Git will check out each commit, run your script, and mark good or bad without you touching the keyboard. What if a commit won't even build? Don't panic and don't guess. Just mark it as skip. Git Bisect skip tells the tool this commit is untestable, and it picks a different midpoint instead. Every step gets logged automatically. Run Git Bisect log to see the full trail of your search. You can even save that log and replay it later with Git Bisect replay on another machine. Once you find the culprit, run Git Bisect reset. This returns you to your original branch and commit. One warning. Flaky tests will wreck this entire process. A test that randomly fails gives Git false answers. Fix flaky tests first, or Bisect will confidently point at a completely innocent commit. Keep your test script minimal. It should check one thing, fast, and return a clear pass or fail. Narrow your starting range before you begin. The tighter the window, the fewer steps you'll ever need. Picture this. A regression shipped 3 weeks ago, buried under 400 commits from 6 different engineers. Without Bisect, that's a full day of guessing. With Bisect, that's 9 steps, maybe 15 minutes total. One team at a mid-sized startup found a memory leak from 2 months back in under 10 minutes. They'd been staring at the wrong file for a week. Bisect didn't guess. It just divided and conquered. So the 16-step search for one broken commit in 64,000? That's not magic, that's just math.